ICE cars are 100% going away at some point. Maybe not tomorrow, maybe not even in the next few years. But yeah, once most countries start banning emission vehicles, it's game over. In other words, EVs are what the world is betting on for the long haul. Even if, right now, they still cost more than ICE cars. But why are EVs so expensive? Why do so many people still push back against them? Well, the answer's pretty obvious. The battery. Batteries can make up nearly 40% of the total cost of an EV. And right now, most of those batteries are lithium-based. In fact, about 75% of the EVs on the road today run on lithium batteries. Here's the undeniable truth. For years, the world has been living under the reign of lithium-ion. It's everywhere, not just in EVs, but in your iPhone, your AC remote, your kids' toys. You name it, it's lithium-powered. But believe it or not, that's about to change. In the not-so-distant future, lithium might be completely replaced, at least in EVs. Why? Because there are tons of new battery technologies being developed around the globe, all with one mission: to kick lithium off the throne. And if you hate Tesla, you might want to brace yourself, because this next part is only going to make you hate them more. Once again, Tesla is about to drop a battery that could change the game. We're talking about something with up to 3 times the energy density of what they're using now. Almost nobody knows what just happened at Tesla, but this new battery, it could completely rewrite the company's future, and it might just be Elon Musk's biggest gamble yet. How powerful is it? How cheap could it get? Let's find out. These new batteries have clearly been in the works at Tesla for a long time. Even though the company has tried to keep it under wraps, internal leaks have made it obvious that Tesla wants people to know they're doing something big to push EV battery technology forward, especially for the affordable model set to launch in the near future. What's mind-blowing is that this new battery is made from materials that are far more common and much cheaper than lithium, yet it delivers 3 times the energy density of current lithium-ion batteries. Of course, no technology is perfect from day one. There are still a few hurdles to overcome. But overall, this battery is already superior in nearly every way. And once those final challenges are solved, this won't just compete with lithium. It could replace it entirely, ending lithium's reign once and for all. Yeah, this is the Tesla A1 battery, the company's first-generation aluminum-ion battery. Put simply, aluminum-ion batteries work much like lithium-ion batteries, but instead of using lithium ions as the charge carriers, they use aluminum ions. Each aluminum ion cell has 3 main components: a node typically made from aluminum metal, where the aluminum ions originate; cathode, built from materials such as graphene or metal oxides to store those ions; electrolyte, a liquid solution that allows aluminum ions to flow back and forth between the 2 electrodes. The key difference lies in the very nature of aluminum. Each aluminum ion carries 3 positive charges, while a lithium ion carries only 1. This means aluminum can move 3 times more energy per ion, boosting energy density without relying on rare materials or complicated manufacturing processes. In theory, this allows aluminum-ion batteries to store far more energy in the same amount of mass compared to traditional lithium-ion batteries. And now, the real-world results are starting to prove that potential. Reports suggest that the aluminum-ion battery technology Tesla is testing has already reached energy densities of over 700 watt-hours per kilogram, a figure powerful enough to completely disrupt the battery industry. To put that into perspective, if you equipped a Tesla with this battery, it could travel over 700 miles. That's about 1,126 kilometers on a single charge. Some estimates even push that number closer to 1,000 miles, around 1,600 kilometers per charge. That's a leap so massive that even the most optimistic EV enthusiasts would have a hard time believing it. Which raises one big question. How did Tesla pull off such a giant technological leap? A clear example really shows the difference. Right now, the Tesla Model 3 long-range AWD can go about 346 miles on a 79 kilowatt-hour NMC battery. And those NMC cells only have an energy density of around 180 to 200 watt-hours per kilogram. But aluminum-ion batteries, they hit about 700 watt-hours per kilogram. That's roughly 3.5 times higher. What does that mean? If you swapped out the Model 3's NMC pack for an aluminum-ion pack of the same size, that car could easily hit around 1,038 miles, over 1,600 kilometers on a single charge. That's not just pushing past today's limits. It's rewriting the standard for the entire EV industry. And while lithium-ion batteries are still widely used today, as we mentioned earlier, they haven't seen any truly groundbreaking leap in energy density for decades. Lithium-ion has been stuck at roughly 200 watt-hours per kilogram for years. Even with Tesla's most ambitious efforts, their 4680 cells, energy density has only climbed to about 275 watt-hours per kilogram, which simply isn't enough to change the game. And that's exactly why there's room for something new, and aluminum-ion is stepping in as one of the most promising answers we've ever seen. That said, we've got to be realistic here. Sure, aluminum-ion batteries can hit 700 watt-hours per kilogram at the cell level, but once you build a full battery pack with the casing, cooling system, and all the extra hardware, that number comes down. And that's exactly why optimizing the pack's size is so critical. It's the key to keeping performance high while also cutting down production costs. So instead of that theoretical 1,000-mile range, a more practical number would be closer to 700 miles. But honestly, that's still enough to blow past anything on the market today. Now, if we look at Tesla's 4680 battery, it's still one of the most advanced battery technologies in the world. But here's the catch. This incredible battery is only showing up in high-end cars. Right now, it's basically limited to the Cybertruck, and even the cheapest variant starts at $69,990. And that raises a big question. Can Tesla actually bring this tech down to more affordable cars like the Model 3 or Model Y anytime soon? The answer, at least for now, seems to be a hard no. The reason's pretty straightforward. Lithium prices keep skyrocketing, which is driving up battery production costs like crazy. Since pretty much all of Tesla's current batteries, LFP, NMC, you name it, including the 4680, still rely heavily on lithium, using the 4680 for cheaper cars is basically a pipe dream. Elon Musk has talked up a storm about launching a compact electric car for around $25,000. But let's be real. That plan's been stuck in neutral for over 4 years. Word is it's finally dropping this November, and no shocker here. Tesla's almost definitely going with LFP batteries for that one. While an energy density of 700 watt-hours per kilogram is certainly impressive, that's not the only reason Tesla is so committed to aluminum-ion battery technology. As Elon Musk has pointed out, the bigger problem is the ever-escalating cost of lithium-ion batteries. This is largely due to the soaring demand for lithium and limited supply, which has led to overmining and ever-increasing prices. This has not only put pressure on the entire EV industry, but has also made it difficult for manufacturers like Tesla to create more affordable models for consumers.
So the price of lithium and all the raw materials and the battery cells went crazy. It doubled. The price of cells doubled. Price of lithium, I think, went up at almost fivefold or 500%. Went up crazy numbers.
Right now, Tesla's using LFP and NMC batteries for the Model 3 and Model Y, while the Cybertruck's rocking the 4680 cells. All three rely on lithium, and they also use pricey materials like nickel and cobalt. A quick Google search will tell you these are some of the most expensive materials for battery production. Even Elon Musk has admitted that the 4680 batteries are actually pricier than traditional ones, since they're packed with all three: nickel, cobalt, and lithium. So, even though the 4680 is cutting-edge tech, the cost is still a major hurdle keeping Tesla from slapping it into more affordable models. If you know anything about the metals in Earth's crust, you probably know aluminum is the most common one. It makes up about 8.13% of the entire crust. Bauxite, the main ore used to produce aluminum, is found across dozens of countries. With global reserves sitting at roughly 1.59 billion tons, aluminum is not only far easier to source than lithium, nickel, or cobalt, but it's also way less vulnerable to geopolitical risks or supply chain disruptions. And that's exactly the golden opportunity for Tesla to slash battery costs like never before. According to the data we've seen, aluminum-ion batteries could cost as little as $40 to $65 per kilowatt-hour once the tech hits full commercial scale. And that number could drop even further if Tesla ramps up large-scale production, something they've already proven they can do with their massive battery lines at the Nevada Gigafactory. Of course, Tesla doesn't regularly disclose details about production costs, and so far they've never officially revealed the actual cost of the batteries they use. However, based on independent analyses, it's estimated that batteries typically account for about 25 to 40% of a Tesla's total production cost, depending on the battery type, vehicle model, and specific configuration. For example, with the Tesla Model Y priced between $45,000 and $60,000, its battery pack ranges from 67 to 82 kWh, applying an average NMC battery cost of around $139 per kilowatt hour. The battery pack's cost would be approximately $9,300 to $11,400, equivalent to 19 to 25% of the vehicle's total value. However, if replaced with aluminum-ion batteries costing only $40 to $65 per kilowatt hour, this figure would drop significantly to just $2,700 to $3,000, $5,300. This means Tesla could substantially reduce selling prices, creating a real opportunity to bring affordable EVs to more people. When Elon Musk chooses to invest in a new battery technology, performance and energy density are always top priorities. However, the most critical factor is scalability. No matter how powerful a battery is, if it's too expensive and only suitable for luxury vehicles, it won't drive real change. That's why aluminum-ion batteries are expected not only to deliver superior performance, but also to solve the production cost challenge, a key factor in enabling Tesla to lower electric vehicle prices and shed its reputation as a company that only sells EVs for the wealthy. Beyond that, aluminum-ion batteries have an advantage that even the most advanced lithium-ion batteries can't match: charging speed. While a modern lithium-ion battery takes at least 20 to 30 minutes to charge to 80%, aluminum-ion batteries can reach a full charge in just 5 minutes, and notably they do so without overheating. This could eliminate one of the biggest barriers preventing wider adoption of electric vehicles. The ultra-fast charging capability of aluminum-ion batteries stems from their fundamental properties. Aluminum ions move through the electrolyte 3 times faster than lithium ions. As a result, charging is not only faster but also maintains optimal performance without stressing the battery's structure. More importantly, these batteries offer superior thermal management, effectively addressing the overheating issue, a critical weakness of traditional lithium-ion batteries. Thanks to these advantages, aluminum-ion batteries are not only faster to charge but also safer and more durable over the long term. Additionally, one of the chronic diseases of lithium-ion batteries, the formation of metal dendrite crystals, is virtually non-existent in aluminum-ion batteries. Dendrites are metal crystals that form during charging, potentially piercing the separator, damaging the battery's structure, and causing serious issues like reduced performance or even fires and explosions. With aluminum-ion batteries, the release of aluminum ions occurs much more uniformly and stably, nearly eliminating the risk of dendrite formation. Studies from reputable institutions like Stanford University have shown that these batteries can withstand tens of thousands of charge-discharge cycles without this issue, a massive leap forward compared to traditional lithium-ion batteries. While conventional lithium-ion batteries typically endure around 2,000 charge cycles before dropping to 80% capacity, equivalent to 4 to 8 years of daily use, some independent studies suggest aluminum-ion batteries can achieve up to 15,000 cycles. This means that with proper use and maintenance, an aluminum-ion battery could last up to 35 years, a true game-changer compared to current battery technologies. The reason for this remarkable durability lies in the physical and chemical properties of aluminum. Physically, aluminum is an exceptionally robust material, widely trusted in modern car frames for its strength and resistance to deformation. Chemically, aluminum is far more stable than lithium. While lithium readily reacts with oxygen and water, leading to material degradation over time, aluminum forms a natural oxide layer when exposed to the environment. This oxide layer acts as a shield, preventing corrosion and maintaining the stability of the anode, thereby extending the battery's lifespan far beyond existing technologies. This is the key point. Tesla isn't just developing a battery that charges faster. It's creating one durable enough to potentially outlast the electric vehicle itself, making battery replacement a thing of the past. But that's not all. Another persistent issue with lithium-ion batteries is the risk of fire and explosion. Lithium batteries can ignite if impacted or overcharged, and the resulting smoke is not only toxic, but also extremely difficult to extinguish. Despite years of research and improvements, this risk has not been entirely eliminated. In contrast, aluminum-ion batteries are nearly immune to this danger due to their stable chemical properties and superior heat resistance, setting a new safety standard for the EV industry. Additionally, aluminum-ion batteries offer a strategic advantage: superior recyclability. Aluminum is the most abundant metal on Earth, and if this technology is widely adopted, it could significantly reduce reliance on expensive and hard-to-mine metals like lithium, nickel, or cobalt. Laboratory experiments have already shown that up to 80% of aluminum fluoride salts can be recovered, with expectations of even higher rates at industrial scale. Notably, the solid aluminum foil from these batteries can be reused almost directly after cleaning, making aluminum-ion batteries one of the most sustainable and environmentally friendly solutions the industry has ever seen. However, no technology is perfect from the start, and aluminum-ion batteries are no exception. A notable challenge is their reduced performance in low-temperature environments, which currently limits their use in colder climates. Nevertheless, this is not an insurmountable barrier. Leading research teams worldwide, including Tesla, are intensely focused on addressing this issue to ensure that aluminum-ion batteries not only excel in performance, but are also ready for all real-world conditions. Currently, aluminum-ion batteries have not been widely publicized and are rarely mentioned in mainstream media. However, if Tesla can successfully commercialize A1 battery cells and integrate them into more affordable vehicle models, it would not only be a technological breakthrough, but also a game-changer for the entire electric vehicle industry. According to internal sources, Tesla plans to produce all aluminum-ion batteries in the U.S. at a new expanded facility adjacent to Giga, Nevada. The production line is expected to begin operations by the end of this year, once all equipment is installed and fully calibrated. In theory, the lifespan of aluminum-ion batteries is truly impressive. No battery lasts forever, but with the potential to achieve up to 15,000 charge cycles, aluminum-ion batteries could last 35 years or more, a figure that lithium-ion batteries cannot come close to matching. This makes them an ideal choice not only for electric vehicles but also for large-scale energy storage systems. More importantly, in terms of cost, researchers believe that when mass-produced, the price of aluminum-ion batteries could be comparable to, or even lower than, current lithium iron phosphate batteries, a possibility that was once considered nearly impossible. Over the past 2 years, lithium prices have been a roller coaster, with brief dips followed by sharp spikes. This year, they surged to $9,200 per ton. The issue isn't just the cost, but also the scarcity. Global lithium reserves are estimated at around 89 million tons, nearly 18 times less than aluminum. More concerning, the majority of these reserves are concentrated in just 4 countries. China holds about 16.5%, with the rest primarily in the lithium triangle of Chile, Bolivia, and Argentina. With such concentrated supply, lithium prices are not only high, but also vulnerable to geopolitical factors.